So I finally made it to ThingMonk. Actually, at this time of the year, I expected different weather. I don't know, what about you? When I was in university, I had a professor, a mathematician professor. He acted like a robot. So he was always on the second, ready with his presentation. Everything was neat and nice on the blackboard. But one day he showed up for a lecture. It was similar temperature like this. And he came up to the shop floor like a robot and saying, hey, this is too hot for me. I stop functioning here. I go home now. So he left the room immediately. So I hope you stay here for my presentation. And I try to make this a little bit entertainment. So when I finally said, yes, I come to London for ThingMonk, which I wanted to do for, I think, 2 years already, the question was what I should talk about. I didn't want to give the standard IoT presentations. We have tons of slides and material in Bosch Group about that one. The last collection I saw this has 120 slides, so you're not missing on that. But I made some new one. And I thought, what should be different in this presentation? Then I found out, yeah, what is different is a good topic. Because what is different in Internet of Things from two perspectives. One perspective is for Internet companies, how they are there, and for the Things companies, what is different in Internet of Things for the Things companies. And I like to explore these two perspectives. Because in the beginning, I always thought it's only different for Things companies, but I learned also that Internet companies have some challenges in IoT. This also includes software companies and telcos operators. So that's the topic of the talk. Just a short introduction of Bosch. Bosch is not a shareholder company. It's owned by a foundation. So 2% of our profit goes to charity. So we are a little bit more long-term thinking, that's why. What is also a little bit different than other companies, we started Bosch Software Innovations as a software and system house for IoT 2008. So we basically put together a small group of people trying to win this IoT game for an industry player like Bosch, and this is our company. And we are working in these fields: mobility, energy, city, manufacturing, and building. And we have a two-side approach, so we do projects and services, and we do also platform business with an IoT platform and cloud technology. And why we set up a company by itself, I was thinking about the decisions we had in the boardroom 2008. One reason was that we understood that the engineers we had within Bosch, it's very difficult to get them to this fast and agile working style. So we acquired 3 companies with that knowledge, and we keep them very separate from the rest of the Bosch Group. In the beginning, I think in the end of 2008, we had even lists of people who were allowed to visit this new company because we wanted to protect the engineers there. So we moved closer and closer to the Bosch Group since 2008, and now we are becoming more and more part of the family. But also Bosch is changing in order to deal with these new challenges. So now I have a few slides about IoT. It's not about that I think that you don't know the topic, but I'd like to introduce a little bit of the terminology and view of we have about it. First of all, it's about B2B and B2C business. It's not only one, it's both. Sometimes it's even B2B2C, where you have to provide a solution that is finally for the end customer, but your closest customer is a B2B customer. It's about services and things. It's a problem with the term Internet of Things that we mostly think it's about connecting a thing, but there's no so much value behind. Like connecting this fan to the internet doesn't have a value. If it produces really something that's cooling up here, provides a service to us, then it has a benefit. Yeah, that's why we had in the beginning also the term Internet of Things and Services, though we skip this now as nobody is using this in the world. We also believe that most of the value and money is in the service side, and that the Internet of Things connectivity is mostly, in the end, a commodity thing you have to get done somewhere. This slide is a little bit strange, as I put cloud and enterprise IT so big in the picture. And the reason is that a lot of companies in Europe, particularly in Germany, underestimate the importance of the cloud technology and also their enterprise IT stack. I think it's more familiar in the US that you have that, you need that. Most of the companies in Germany don't invest that much in that space, and that's a problem. Also, it's easier to start with cloud technologies. Cloud scales easily, is everywhere, rather fits to what we need in IoT. We have very small projects right now, few technology to connect, but we scale up in the future. This doesn't fit so well to enterprise IT. But if you think that you can just work on cloud technology, it's also a little bit short-sighted, as a lot of data is already stored in enterprise IT. Just think about all these Oracle databases and SAP systems we have already. So we, even if we're running an application here, need also data and connectivity to enterprise IT, which has a lot of challenges in terms of opening up the firewalls, getting access to the data. And Clemens, there's a small link to the MES system here. This red line here is a very difficult one, because today in production, you protect the enterprise IT from the nasty devices in production, because they are running very old Windows operating systems, some things like Windows NT 3.5. Remember that? No security patch on that. And you don't want to have this in your corporate network. So that's why we have firewalls here to protect our enterprise IT from production. And getting connectivity just done there is a lifetime project, also organizational-wise. So that was about IoT, but all this technology, all this connectivity, does this really help us to make something that makes sense? Of course, we can make money with that. That's the point. When I started to work in this field in May 2009, I put up this chart at the left corner of my whiteboard. And I said, why I'm doing this here? What is the purpose of it? And for me, purpose means it's something that is serving mankind on a bigger scale. And I picked out 3 of these topics and said, this is what I'm working on. And every time I'm desperate or tired, I go back to this chart and see I'm still on track for that. So I picked number 1, sustainable development and climate change, the global convergence of IT, and the energy topic. You can look at this study that's done by the United Nations in a very interesting crowdsourcing approach. So they were asking everybody in the world to contribute the most social challenges they see. Just understanding how this process worked and the results that came out of that is interesting. The link is down there. Yeah, so now I come to what is a little bit new in the presentation today, patterns in IoT. As we were starting our first projects in 2008, we did a lot of failures in IoT. We did not really find the shortest path to success in IoT, and we're still struggling here and there. And I'd like to give you some of the learnings in terms of patterns. And the first learning was, I think, it was Kai presenting or preparing a workshop we had in 2013, why we have difficulties getting all the different use cases solved with the same message bus, with the same enterprise service bus, with the same BPM software. And Kai was putting up a chart like this and said, yeah, we have very different use cases out there. And I'd like to lay out these use cases now a little bit. One dimension is the time. What time you're looking in a certain use case or system. Is it rather milliseconds, or is it months or years of data you collect? And the other dimension is how much data are you really interested in? Is it a few bytes, or is it petabytes and gigabytes of data? And if you look at these different requirements, you come up to very different patterns. On the right top corner, you have pumping data continuously, not thinking about whether you need it, you just get every data you can get hold of. Next to that is the typical stream processing. So they have a lot of data in short time, like video analytics and stuff like that, and you pipe this through. If you just act on short-term cycles and have not so much data, it's the area of signal processing. And the right corner, you rather look at topics like predictive maintenance, where you have few data sets, you're looking upwards for a month. So these are very different problems to solve, and you cannot expect one technical system to solve them. So you need different approaches for them. It doesn't mean that you cannot have a platform for that, but it does mean you cannot have just one communication protocol, just one database, or just one enterprise service bus for that. And you see how big the differences is. I put some numbers and some specific use cases to that. For example, can you still read this here, or is it too small for you in the back? These are gigabytes per month and per car. So we have a project where we collect field data from cars. This is to understand which car is failing for what reason. And if you ask this question, you don't know which data you should collect because you only know afterwards. So you collect everything you can get. And we dump this into a MongoDB. You can also take a Hadoop cluster for that. And the amount of data we get in there is quite interesting. Actually, we had to call the Mongo guys once to help us to get the database really getting bigger. Stream processing, there are very excellent examples with video and voice recognition streaming. Video, we have an application where we can identify suitcases not being moved for the last half an hour, so missing an owner. And then we can raise an alarm because it could be really a bomb in there. There we talk about kilobyte per millisecond. Where it gets very nasty in terms of timing, if you look at timing for a CNC machine, you process only a few bytes. You don't store a lot of data there, but it has to be done in microseconds because the stuff is moving so fast. Or if you look at engine control unit, which is next to that, if you should ignite the engine, there's no question about timing. If you miss the next cylinder to jump the spark plug, well, you can kill your catalyst with that. Just one spark, basically. And this is about bytes per nanosecond. And predictive maintenance, I picked the use case we have. We have a lot of electric motors. There are certain patterns where you can understand whether they are failing. So what you do, you look at current and voltage, you do an FFT, a Fourier analysis, and you store the coefficients. So in this case, you look at some time frames, like weeks, sometimes only days. You store these coefficients and then make an estimate how fast this engine will fail. So very different patterns behind, and we saw the examples for that too. So we can say that Internet of Things is Internet, but then with these requirements, you also see different kinds of protocols are coming out there. So you know the stack exemplary for typical web applications on the left-hand side. If you see an example how an efficient internet protocol is done nowadays, it is not so much different, but in practice it's very different. Just starting IP version 4 is not really a solution for IoT. A lot of our devices turn off to save battery power. They are not so strong on computation too. They're not always on. So at least you need an IP version 6 or this even better, a 6 low VPAN. Then TCP is not a good approach for constrained devices. UDP is much better. But just look at the infrastructure for UDP. Getting a load balancer working for UDP, getting all the internet infrastructure set up for UDP. You think it's a given? Nah, it's not really everywhere. DTLS, encryption for constrained devices, yes, it's there, but it's not everywhere. And CoAP as a representation of HTTP on the same level for constrained devices. So many cases you move on data to binary format, to more efficient. And though both stacks have their advantages, they are both there. They will still continue to be there. There's also some variations of this, but it's not really the same. It's different. What's also different is how we deploy applications. Now I come up with some patterns, how distributed IoT applications are and how difficult they are to handle then in practice. Web applications are, I make this a little bit oversimplistic now, very simple. You have computers, smartphones or tablets and the cloud. And this is basically where you deploy things. You have some JavaScript code running in a browser and some software on the server. IoT applications never work, and that pattern alone, you need much more. And now we come to some of these solutions. A very early pattern is often called M2M. This is where you have a VPN connection of one of the things to an enterprise IT systems. That's where we basically started, even in the 70s. It was at the time when MQTT was invented to do such a use cases. And then you have users accessing the enterprise IT system. This system has a problem. It's not really ready for tenants. The VPN connection, the enterprise IT, it's basically meant to run in one company. You can only scale so much with applications because enterprise IT is not really made for scaling. So you have to ask your IT to set up new systems, and 3 months later you have new computers, and then you have a new internet connectivity, and so on and so on. So this is one dominant pattern we have today. Another one comes from the consumer electronics. If you buy a new digital camera, if you have a bicycle out there, and you buy connectivity for these devices, it's mostly that you have a local connectivity, like you have a Wi-Fi, a Bluetooth connection, and then you are able to interact with this device. So I would say this is rather a smart remote control with your iOS or Android device. And here you have even less flexibility. It's usually one user, one tenant, one application, and one device. It's really one-to-one mapping. I don't know, do you have a digital camera? Try to share the same data with your family? No way you can do that easily. So this is what we have in the market today. And I a little bit perceive that everybody thinks this pattern number 3 is the future of IoT. So there you have a gateway, like in a smart home case. You collect local protocols together. You connect it to the cloud, and then you scale. It's okay for 20,000 users, multiple tenants, few applications. And I see an example of this with about 200,000 things out there. But I believe this is not really the future. As we saw today, each and every application is built by its own silo. So we have one for smart home, one for your car, one for, I don't know, your dishwasher, one for, and so on. And you end up, like I have, about 50 different apps with different users, passwords, various communication. And I think you saw the talk, the terror of connectivity in your smart home already. That's exactly where it's leading us. So pattern number 3, IoT gateway, is in the market, but it's not really the solution for what we are striving for. So there are variations of these patterns. As one example is down here. There you use the smartphone to connect devices. And we have also within Bosch an example of that. This is a Bluetooth tag you can connect or tie to your power tool or any other thing. And it uses your smartphone to detect this tag and service this device to the cloud. The advantage is a business case. You usually have a smartphone already. You already pay a service fee for connectivity. You have the expensive smartphone, and you get an additional use case for a few euros. And in many cases, connectivity costs are so high that you cannot afford an additional gateway or additional device for these use cases. Then there's also a variation of this pattern, very often in smart home. There you have a gateway for smart home connectivity, and you can use the smartphone to either access the gateway directly in Wi-Fi, or you use smartphone remotely if you are away from home. The local connectivity is required because sometimes internet connection is down and you still want to switch on your light, even the internet is down, is something that makes sense. Also sometimes you do not want to share all the data with the rest of the world and rather keep it with you. Then you keep this on the gateway. Yeah, believe it or not, I don't believe these patterns are the future too. So there's one more pattern coming up, and I call this pattern 42, the pattern to solve all the problems. And I strongly believe we can only make the Internet of Things really a purposeful system if we really connect all the devices with semantic interfaces to the same platform, and then allow thousands of developers or DevOps people to build the applications on top and serve this market. There's no other way around. Otherwise, we end up with a vertical solution of nice tiny applications, but we will never really get the huge benefit of an interconnected infrastructure. Yeah, so that's the job to be done. And of course, we know at Bosch we cannot do this ourselves. It needs a lot of partners. And the best way to partner is actually to do this in an open source way. Here you see the Eclipse IoT projects. I hope I did not forget any logo. That's important. Please tell me otherwise. Kai was talking about it, how this all works together in the end and how we are pushing this forward. And we strongly believe this can only be done in open systems. It's open source, it's open standards. It has to be a way that the community in the world, either with de facto standards in open source or with formal standards and standardization bodies, can bring this forward. Yeah, we're committed to this one. And just to give you the concrete examples, how we are connecting this, the sensor I even have with me, that is this one here. I have a small demo also with me that's very nice for programmers, as we are also producing a lot of sensors for cars and smartphones. You probably have a few sensors in your pocket that come from our factory in Reutlingen. And they are so small, they are just tiny black pieces on the board here. And 10 of these sensors are on this experimental board you can use for programming. So that's a nice toolkit to run your application. Yeah, now I come to these two concluding slides. So what is really different? What is different for internet companies in Internet of Things? And Internet was not really built with security, safety, and reliability in mind. It was mostly built for interoperability, for openness, for sharing everything. But if you're able to open your door, if you're able to run a car, if you're able to think around with production machines, security and privacy become a point. I don't want to dig too deep into this, but it's important that things security is very different from the security of servers. Things are in, we always say, enemy's hand already. So if you sell a smart home, you can sell it to a hacker, and he has the gateway, and he has all the time, like years, to hack through this. It's even worse. This hacker is a customer. We have to serve him. So even if he's hacking him, he still can say, well, you have to provide me the service, even though I'm hacking your system. So it's a very interesting stakeholder or anti-stakeholder. The cost dimension is also very different. Cost of connectivity. We cannot really afford connectivity cost like for a laptop or a smartphone. If we spend connectivity costs with 10 cents per year, that's sometimes something we can afford. But some use cases really unfold only if you're cheap in connectivity. Constrained devices, you either have local connect with a local protocol, or you have very low battery power, which also means that you're not always on for the terms of saving power. Also, reliability is very different. You need always local redundancy in these use cases. You cannot really rely on that internet is not there and your functionality stops. This whole safety topic is a discussion point by itself. I'll just give you an example. If a crane crashes, the authorities really freeze everything around the plane. And have you ever seen this? They are making a special zone around this, and they try to get each and every evidence about this plane. So what happens if something crashes in the internet? Can you freeze the internet? Next day, the system is completely different. So we don't have any mechanisms for auditing and also no mechanism to bring redundancy for safety in there. Safety critical system, there's some interesting design patterns that are very well known for embedded developers, but not even understood by I would say enterprise developers or IT companies or internet companies. They usually have 3 layers, one with normal functionality, one with a very simple functionality, which is known to be safe, but not that sexy, of course, but it's safe. And then the 3rd layer, which decides whether we are in a situation where safety is the first thing to do and forget about all the nice features. Yeah, and important point for internet companies is domain know-how. You see a lot of internet companies starting to acquire companies with production knowledge, domain experience. I don't want to give you the examples, also very expensive acquisitions behind this one. This is the point for internet companies. The things companies have the other problem. They have to acquire the knowledge for cloud, connectivity, and compute. So what's different for things companies? So as I'm a thing company, I feel this every day. It's a major culture shift. That's why I believe it's more difficult for things companies to adapt than for the internet companies. But it is really the different way of dealing with customers. An Internet of Things customer is always on. He's always connected with the company, with you. Everything he's doing, you know. Today, if you sell a piece of hardware, when you get a call from a customer, usually it means the system is broken. If nobody is calling, that's a good sign. Then you did your job right. So this always on, this customer relationship is really new. Also, it comes with different business models. If you are always connected to a customer, you have recurring revenue models, or you have subscription models, you have freemium models, something that you're really used to in your hardware business yet. Innovation cycle is what most companies struggle with. Like, typical innovation cycle for a car is 5 years. But what mobile phone is going to work in 5 years, you don't even know. You just know the mobile phones today won't work with that car anymore. Yeah, then we have this field of ecosystem, horizontal integration and open source. Things company used to have a supplier and a customer, a B2B customer. And that's it. There's no space for partners. And horizontal integration is not really there. It's mostly vertical integration. The know-how, I said already, cloud connectivity and software are the key ones. And what's very difficult for things companies is making the developer a first-class citizen. I made the developer a little bit smaller than the customer relationship. It depicts a little bit the situation also. But it's also key, because we know we need about 5 million IoT developers in 2020 to come up with all these applications. And there's no company on planet Earth can hire so many. So we really have to get them in. And I'm really happy that we at Bosch made this transition to make developers first-class citizens. So I'd like to invite you for our next hackathon in Berlin, where you get all this cool hardware we have in our companies, from cars, production machines, sensors, very cool stuff. You can really hack the real hardware, and I think this is something you like to do. But anyhow, this transition from having a conference, but also having a hackathon where we also spend money on developers and attracting developers, was a longer journey, and we finally made it here. So that's my last slide. Thank you for your attention, and